Welcome everybody. So I would like to add some more slides to chapter 9. So the extra slides, they stem from our class today. So we made clear that we always want to use like this utility function. Utility depends on the quantity consumed of good 1 to the power of 0.5 times the quantity consumed of good 2 to the power of 0.5, or like the utility is equal to like the square root of q1 and the square root of q2. Now I would like to know how large is the utility level in the different scenarios, like scenario A, B, and C. Let's check. Like we have to insert the quantity of consumed of q1 in this part and the quantity consumed of q2 in this part. And then we have to take the square root of 9, which is equal to 3, and the square root of 36, which is equal to 6. So the utility level in the first scenario is equal to like 18. Let's check scenario B. So q1 is equal to 1. So I plug in the 1 here. And q2 is equal to 100. So I plug in the 100 here. So the result is 1 times 10. So the utility level is equal to 10. What happens if the quantity consumed of the first good is equal to 0 and the quantity consumed of the second good is equal to 101? So in this scenario, it is the case that we have to plug in the 0 here. The square root of 0 is equal to 0, and hence the utility level will be equal to 0. So we have to at least consume a little bit of Q1 in order to reach a positive utility level overall. Yeah, like this was the result of the first assignment in class, and I will also upload the slides on its learning. The second task was as follows, like we wanted to draw a budget line for one consumer. The income was given by $30 and the two prices were given as the price of the first good was equal to $3 and the price of the second good was equal to $15. So we should draw a stylized budget line like by hand, not by Excel. And then we should answer the question, how large is the slope of the budget line? So like we said in a first step, like we have to put the right labels on the two axes. And the students were guessing, what do we put on the horizontal axis? One student said P2 and I said, no, this is not right. So the next student said P1 and this is also not right. So we put Q1 on the horizontal axis and like Q2 on the vertical axis. Why are we not putting P2 and P1 on the two axes? Because like these variables are known, like these variables are given in the assignment, so it doesn't make sense like to put these variables on the two axes because there is no variation in the prices. Like how do we get the budget line? So in the first step, we think about what if we are consuming nothing from good 1. So Q1 is equal to 0 and we are spending all of our income on the consumption of good 2. So our income is equal to 30. The price of good 2 is equal to 15. So we can afford 2 units of good 2. And we have determined one point of our budget line. The other extreme is when we are consuming no goods Q2 at all. So Q2 is equal to 0. How many units of Q1 can we consume? This is given by 30 divided by 3. So the income divided by the price of good 1. And hence we can at max consume like 10 units of good 1. What about the slope? Like when we go one step to the right, then the curve goes like minus 0. Step downwards. So the slope of the curve is given by dq2 divided by dq1. The change in the quantity of good 2 is equal to minus 0.2. So we have to reduce the consumption of the second good in case that we want to consume 1 unit more of the other good. and hence the slope is a negative 0.2. Why is it the case that the slope is equal to minus 0.2? Because the slope of the budget line is given by the ratio of the two goods prices. So like the slope is given by P1 over P2. P1 is equal to 3, like P2 is equal to 15. So when the 3 cancels out, we are at minus 1 over 5, or like minus 0.2. Like this is the solution to this question. Like we want to draw a consumer's budget line, income is given, the two prices are given, and we should draw like a stylized budget line, and we also answered the question, what is the slope of the budget line? Nevertheless, like in our class, we had a discussion about what kind of formula can we use in order to compute like the slope of the budget line, and I would like to go into this discussion. But in the first step, I also draw this relationship in Excel. So on the vertical axis, we have Q2, like the sodas, and on the horizontal axis, we have Q1, the movies. At max, we can consume like 10 movies, or at max, we can consume 2 sodas. And like this is like the slope of the curve is given by minus 0.2. Like some extra slides, like the following picture stems from the textbook, page 54. And here we are working in one diagram where we have a y variable on the vertical axis and the x variable on the horizontal axis. And here it is said that this curve has a negative slope, and the size of the slope is like a negative minus 3 over 4. Why is that? Because when we walk like from the first point, from this point to the second point, we have to give up like 3 units of the y variable in order to get 4 units of the x variable. So the ratio is like minus 3 divided by plus 4. It is like minus 3 over 4. Let's have a look once more. So like the slope of the curve is given by, like in this graph, they are using like the delta, like the change in the y variable and the change in the x variable. I like to use the variable d in order to show like the difference in the y variable. The y variable changes from 6 to 3, so it's a reduction by 3 units. So the change in the y variable, the difference in the y variable is minus 3. What about the x variable? The x variable changes like from 2 to 6, from 2 to 6. So the change in the y variable, the differences in the x variable is equal to like plus 4 units, and hence the slope is a negative 3 over 4. In case that we put Q2 on the vertical axis and Q1 on the horizontal axis, then it will be the case that the slope is given by the following relationship. So we put Q2 on the vertical axis instead of y, and Q1 on the horizontal axis instead of x. And then the slope is given by dQ2, dQ1 equal to minus 3 over plus 4. So it's a minus 3 over 4. One question in class appeared, like, can we also use this formula? How does the formula look like? The slope or the steepness of a line is found by dividing the vertical change, the rise, by the horizontal change, like the run. The formula is given as follows, like slope is equal to like y2 minus y1 divided by x2 minus x1, where like x1, y1 are the coordinates of the first point, and x2, y2 are the coordinates of like the second point. And the answer to the question of the student is, yes, you can use this formula, of course, but you need to know how to apply it. So let's check. we said we have like our first point here. This is point 1. And the coordinates of the first point are like x is equal to 2 and y is equal to 6. This is point number 2. And the coordinates of point number 2 are like x is equal to 6 and y is equal to like 3. Let's plug in these numbers into this magic formula. The first point is like x is equal to 2, y is equal to 6. And the second point is x is equal to 6 and y is equal to 3. So like y2 is equal to this 3 here, and y1 is equal to like the red 6. x2 is equal to the black 6, and x1 is equal to like the 2 here. So we get 3 minus 6 is minus 3. The change in the y variable is minus 3. And the change in the x variable is 6 minus 2, it's a plus 4. So once more, the slope is minus 3 over 4. So of course you can apply this formula. It definitely will work, but you need to know what you are doing. So please understand, like the magic formula, which you have learned so far, is related to what we did in class. So in the numerator of this fraction, we have the change in the y variable, and I denote the change in the y variable as dy. And in the denominator of this fraction, we have the change in the x variable, x2 minus x1, and I denote it as dx. This is very important that you understand this relationship in case that you want to use like this formula here. So the slope is given by either y2 minus y1, which is equal to the change in the y variable, or x2 minus x1, which is like the change in the x variable. Let's go back to our budget line. So like I put in the y variable on the vertical axis and the x variable on the horizontal axis. Point 1 is like x is equal to 0 and y is equal to 2. Point 2 is x is equal to 1 and y2 is equal to like 1.8. And hence, we can also use this formula. We only have to consider that 0 and 2 are the coordinates of point 1, and 1 and 1.8 are the coordinates of point 2. So, like we have to say y2, we find y2 here, which is 1.8, minus y1, which is 2. So we have 1.8 minus 2 here. And then in the denominator, we have the change in the x variable. So this is x2, which we find here. And this is like x1, which we find here. So we also have here the relationship. We have here like the change in the y variable, which is equal to minus 0.2. And here we have the change in the x variable, which is like a positive 1. And hence also here the slope is a negative 0.2. So it is really the case that we can use this formula. Nothing is wrong with this formula, but we need to know how to apply it. And I think it's much easier to stick to our convention that we put like Q2 on the vertical axis, Q1 on the horizontal axis, and then the slope is given by dQ2 divided by dQ1. And in economic terms, this is given by this price ratio here. Thank you very much for watching this video. Have a nice day. Bye-bye.